For area of a triangle, half into length of A cross B. For area of a parallelogram, whenever the adjacent sides are given, it is length of A cross B. U is nothing but A dot B, vector A dot B plus vector B dot C plus vector C dot A. This is very important problem. Vector A dot B plus vector B dot C plus vector C dot A is equal to minus 3 by 2 is the difference. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. In my previous class, we have discussed regarding the dot product and the cross product of vectors. So, in this session, I am going to take few more problems based on the cross product or vector product of the vectors. Let us come to the first problem. What is the problem given? Find the area of the parallelogram whose adjacent sides are given by the vectors. Vector A is equal to I cap minus 2j cap plus 3k cap, and vector B is equal to 2i cap minus 7j cap plus k cap. Now suppose if A and B are any two vectors, if A and B, let us come to the solution. If A and B are any two vectors, represent the adjacent sides of a parallelogram. If A and B are any two vectors, this is vector A and this is vector B, represent the adjacent sides of a parallelogram, then the area of this parallelogram is given by area of the parallelogram. Area is equal to length of A cross B. The area of the parallelogram is length of A cross B. Just keep it in mind, if A and B are the adjacent sides of a triangle, then the area of a triangle is half into length of A cross B. If A and B are the adjacent sides of a parallelogram, then the area of the parallelogram is given by half is not there, only length of A cross B. For area of a triangle, half into length of A cross B. For area of a parallelogram, whenever the adjacent sides are given, it is length of A cross B. Now, the area is given by area of parallelogram is equal to length of vector A cross B. Now find out A cross B first. A cross B is equal to, the cross product is nothing but the determinant I, j cap, k cap, and the coefficients of the vector A. I cap is 1, j cap is minus 2 and k cap is 3. And this is 2, minus 7 and 1. Now just simplify this. Now this is plus, minus and plus. Expand with respect to first row. This is equal to I into minus 1 into 2 is minus 2, minus into minus plus, 7 3s are 21, minus j into, this is gone, 1 1s are 1, minus 2 3s are 6, plus k cap into, this is gone, 1 into minus 7 is minus 7, minus into minus plus 2 2s are 4. So this is equal to 21 minus 2 is 19 I cap. Again 1 minus 6 is minus 5, minus into minus it is plus 5 j cap, minus 7 plus 4 is minus 3, minus into plus it is minus 3 k cap. This is A cross B, the cross product of A and B. Followed. Now listen to me, I will explain once again. The area of a parallelogram is A cross length of A cross B. Find out A cross B first. A cross B is equal to determinant I, j, k and the coefficients of I, j, k in both the vectors A and B, 1, minus 2 and 3, first row, second row, and the third row is 2, minus 7 and 1, 2, minus 7 and 1. Expand with respect to first row, plus into, plus I into, minus 2 into 1 is minus 2, minus into minus plus, 7 3s are 21, minus j into 1 1s are 1, minus into plus it is minus, again 6, plus k into, 1 into minus 7 is minus 7, minus into minus plus, 2 2s are 4, 21 minus 2 is 19, 1 minus 6 is 5, minus into minus plus, again minus 4, minus 7 plus 4 is minus 3, this is minus 3i. A cross B is equal to 19i plus 5j minus 3k. Let us find out the length of A cross B. Now, length of A cross B is equal to modulus of 19i, magnitude of this, plus 5j cap minus 3k cap. Now this is equal to square root of 19 square plus 5 square plus minus 3 square. Okay, this is equal to 19 into 19 is 361 plus 5 5s are 25 plus 3 3s are 9. This is equal to 361 plus 9 is 370. 370 plus 25, 70, 80, 95, 395. So therefore, area of the parallelogram is equal to, area of the parallelogram is length of A cross B is square root of 395 square units. So this is the required area. Area of the parallelogram is length of A cross B, that is square root of 395. That's it. Hope you followed this. Now let us come to the next problem. Same time. Find the area of a parallelogram with vectors A is equal to 3i plus j plus 4k and vector B is equal to I minus j plus k as the adjacent side. Same type problem. If A and B are the adjacent sides of a parallelogram, then the area of a parallelogram is length of A cross B. Now find out A cross B here. What is given? A cross B is equal to determinant I cap, j cap, k cap and the coefficient of I, j, k in vector A and B. Now given A and B, write down the coefficients 3, 1 and 4. For the second vector it is 1, minus 1 and plus 1. Expand with respect to first row. So this is equal to I into 1 ones are 1, minus into minus plus 4, minus j into, delete the row and column containing this, 3 ones are 3, minus 4 plus k cap into, this is gone, 1 into minus 3 is minus 3 minus 1. This is I cap, 1 plus 4 is 5, minus j cap into minus 1 plus k cap into minus 4. This is equal to vector A cross B is equal to 5i, minus into minus plus j, minus into plus it is minus 4k. So A cross B is equal to, cross product of A and B is equal to 5i plus j cap minus 4 cap. This is a vector. Now find out the length of this. Length of A cross B is equal to the magnitude, that is equal to square root of 5 square plus 1 square plus minus 4 square. This is equal to square root of 5 square is 25, 1 square is 1 plus 4 square is 16. So this is equal to 25 plus 1 is 26 plus 16, that's equal to 42. Now therefore the required area, therefore the area of parallelogram is equal to length of A cross B, that is equal to square root of 42 square units. So the required area is equal to length of A cross B, that is equal to square root of 42 units. So for the given problem, the area of the parallelogram is square root of 42 square units. So if A and B are the adjacent sides of a parallelogram, then the area of a parallelogram is length of A cross B. And if A and B are the adjacent sides of a triangle, then the area of a triangle is half into length of A cross B. Now suppose if instead of adjacent sides of a parallelogram, if the diagonals are given, if D1 and D2 are the diagonals of a parallelogram, then the area of a parallelogram is given by half into length of D1 cross D2. That is, if D1 and D2 are the diagonals of a parallelogram, then the area of a parallelogram is half into D1 cross D2, length of D1 cross D2. Now let us consider one more problem based on the diagonals of a parallelogram. Now find the area of a parallelogram whose diagonals are A 2i plus j plus 4k and B I minus 2j plus 2k. Suppose if A and B are diagonals of a parallelogram, then area of parallelogram is equal to area of parallelogram is equal to half into length of A cross B. Suppose if D1 and D2 are the diagonals, D1 and D2 are diagonals of a parallelogram, then area is equal to half into D1 cross D2. this is. If A and B, instead of D1 and D2, they have mentioned it as A and B. If A and B are the diagonals of a parallelogram, then the area of a parallelogram is half into length of A cross B. Now, let us come to this problem. What is A? Find out A cross B first. A cross B is equal to length of A cross. First A cross B is determinant I, J, K. Write down the coefficients of I. 2, 1 and 4. Here it is 1, minus 2 and 2. A cross B. Find out first cross product of A and B. A cross B is determinant I, J, K. The coefficients of I, J, K, the first vector are 2, 1 and 4. And the coefficient of I, J, K unit vectors are 1, minus 2 and 2 in the second vector. Expand with respect to first row. This is plus, minus and plus. I into 1 2s are 2, minus into minus plus, 2 4s are 8. Minus j into this row and column is deleted, 2 2s are 4, minus 4. Plus k cap into, this is gone, 1 2s are 2, 2 2s are 4, minus 4, minus 1. Let us check once again. I into 1 2s are 2, minus into minus plus, 2 4s are 8, minus j into this row and column is gone, 2 2s are 4, minus 1 into 4 is 4, plus k into minus 2 2s are 4, minus 1 into 1 is 1. So, 8 plus 2 is 10 I cap, 4 minus 4 is 0 j cap, again plus k cap into minus 4 minus 1 is minus 5. So, this can be written as 10 I cap, 0 minus 5 k cap. Now, find out the length of A cross B. Length of A cross B is equal to square root of 10 square is 100 plus 5 square minus into minus plus 25. This is 125. Now, therefore, the area of a parallelogram is, therefore, area of a parallelogram, whenever the adjacent sides are given, is equal to half into length of A cross B. This is half into square root of 125. So, this is square units. So, the required area is equal to half into the area. So, the area of the parallelogram is half into square root of 125 square units. Okay, that's all. So, if the diagonals are given, it is half into length of A cross B or half into length of D1 cross D2. If A and B are the adjacent sides, then it is just only length of A cross B. That's it. Now, this type of problems are very, very important for 3 marks. Now, 3 vectors A, B, C satisfies the condition A plus B plus vector A plus vector B plus vector C is equal to 0. Evaluate the quantity mu is equal to A dot B plus B dot C plus C dot A if length of A is equal to 3, length of B is equal to 4 and length of C is equal to 2. This is very, very important problem for 3 marks. What is given? 3 vectors A, B and C satisfies the condition vector A plus B plus C is equal to 0. What is required to find? To find A dot B plus B dot C plus C dot A when length of A, length of B and length of C are given. Now, what is given? Let us solve this. Given length of vector A is equal to 3, length of vector B is equal to 4 and length of vector C is equal to 2. Further, what is given? A plus B plus C. A plus B plus C is equal to 0. Now, let us square this. Squaring on both sides. A plus B plus C whole square is equal to 0. A plus B plus C whole square can also be written as A plus B plus C dot A plus B plus C vector is equal to 0. Now, simplify this. Apply the dot product for this. A into A dot A dot A plus A dot B plus A dot C. Similarly, B dot A plus B dot B plus B dot C. Again plus C dot A, this is C dot A plus C dot B plus C dot C is equal to 0. Okay. Listen, this is the first step. A plus given length of A is equal to 3, length of B is equal to 4 and length of C is equal to 2. And further given condition is that this is given A dot yes. A plus B plus the length of A, yes, vector A vector plus vector B plus vector C is equal to 0. Squaring on both sides, what you will get? A plus B plus C vector whole square is equal to 0, or vector A plus B plus C dot vector A plus vector B plus vector C is equal to 0. Now, A dot A can be written as length of A square. A dot B and B dot A are same because dot product is commutative. So, A dot B plus B dot A is nothing but 2 times A dot B. A dot C and C dot A are one and the same. So, this is 2 times A dot C. Again, B dot B into B dot B can be written as length of B square. C dot A and A dot C can be written as 2 times A dot C. And length of C into length of C, that is C dot C is nothing but length of C square. So, I will go to the next page. So, therefore, the given equation becomes length of A square plus 2 times A dot B, then plus B dot B into B dot B is nothing but length of B plus 2 times B dot C plus length of C square plus 2 times C dot A is equal to 0. This is length of A square plus length of B square plus length of C square. I can take 2 common factor, 2 out, A dot B plus B dot C vector plus C dot A vector is equal to 0. Now substitute the values of A and B. What is A? A is equal to 3, B is equal to 4, C is equal to 2. This is 3 square plus 4 square plus 2 square plus 2 times A dot B plus vector B dot C plus vector C dot A is equal to 0. That's it. Now simplify this. 3 square is 9, 4 square is 16 plus 2 square is 4 plus 2 times A dot B plus vector B dot C plus vector C dot A is equal to 0. So this is 16 plus 4 is 20. 20 plus 9 is 29. Transfer 29 to the right hand side. Then we will get 2 times A dot B plus B dot C plus C dot A vector is equal to minus 16 plus 4 is 20 plus 9 is 29. So therefore A dot B plus B dot C plus C dot A is equal to minus 29. Bring this 2 to the denominator. So this is the required answer. This is what we want to find. Therefore this quantity mu is equal to, mu is A dot B plus B dot C plus C dot A is equal to minus 29 by 2 is the required answer. Hope you followed. So therefore mu, the required answer mu is equal to minus 29 by 2. What is mu here? Mu is nothing but A dot B vector A dot B plus vector B dot C plus vector C dot A. This is very important problem. Okay. Alright. So here if you know the formula for A plus B plus C whole square, straight away you can put this A plus B plus C whole square, vector A plus vector B plus vector C whole square can be written as the length of vector A square plus length of vector B square plus length of vector C square plus 2 times A dot B plus vector B dot C plus vector C dot A is equal to 0. If you want, you can start from here itself. Once if you know if you are familiar with the formula, you can do. Otherwise, simplify the formula and substitute it. Now, let us come to the next same type. Let us take one more problem. Now, 3 vectors, vector A, vector B and vector C are unit vectors satisfying the condition that vector A plus vector B plus vector C is equal to 0. Then find A dot B plus B dot C plus C dot A vectors. So, same problem here. What is A, B and C? A, B and C are the unit vectors. Unit vectors means whose length is equal to 1. So, length of A is equal to 1, length of B is equal to 1 and length of C is equal to 1. That's given. That's it. This is very important problem again. Once again, solution. Now, what is given? Given that length of A is equal to length of B is equal to length of C is equal to 1. So therefore, length of vector A is equal to 1, length of B is equal to 1 and length of vector C is also equal to 1. Further, what is given? vector A plus B plus C is equal to 0. Now what is required to find? A dot B plus vector B dot C plus vector C dot A, same as that of the previous problem, squaring on both sides. So this can be written as length of A plus B whole square is equal to 0. This is, so A plus B plus C vector dot vector A plus vector B plus vector C is equal to 0. So this is length of A square plus length of vector B square plus length of vector C square plus 2 times vector A dot B plus vector B dot C plus vector C dot A is equal to 0. Since we know what is the value of A, length of A is equal to 1 square is 1, length of B is also 1, 1 square is 1, plus length of C is also equal to 1, 1 plus 1 is equal to 2 times A dot B plus B dot C plus C dot A is equal to 0. Now, so just keep this 2 into A dot B plus B dot C plus vector C dot A and transfer this 1 plus 1 is plus 3 can be written as minus 3. So therefore the required answer A dot B vector plus vector B dot C plus vector C dot A is equal to minus 3. Bring this to the denominator. So in the examination, if they're absent this as mu, then mu is equal to minus 3 by 2. So what is the required answer? If A comma B comma C are the unit vectors, then A dot B plus B dot C plus C dot A is equal to minus 3 by 2, provided vector A plus vector B plus vector C is equal to 0. This is also very, very important. So what is the required answer? Vector A dot B plus vector B dot C plus vector C dot A is equal to minus 3 by 2 is the required answer. Okay, hope you followed this. What is our next problem? Let us come to this problem. You let A come vector A, vector B and vector C be the 3 vectors such that length of A is 3, length of B is 4 and length of C is equal to 5, and each one of them is perpendicular to some of the other 2 vectors. This is very important condition. Each one of them is perpendicular to some of the other 2 vectors. Then find the magnitude of vector A plus B plus C. Now this is very important problem indeed again. Now given, what is given? Each one of the vector is perpendicular to the sum of the other vectors. So if 2 vectors are perpendicular to each other, means their dot product is equal to 0. If A dot B is equal to 0, if A is perpendicular to vector B, implies vector A dot B is equal to 0. Here what is the condition? Each one of them is perpendicular to some of the other vector. First vector is perpendicular to some of the other vectors, means the dot product of the first vector and this vector is equal to 0. That is the given condition. Given that each vector A dot B plus C is equal to 0. This is given. Again A dot B plus C. Similarly B dot C plus C vector is also equal to 0. And similarly vector C dot A plus B is also equal to 0. This is the given condition. What is required to find? To find length of vector A plus vector B plus vector C. Okay. Now square this. Consider the magnitude of A plus B plus C whole square. Now if you simplify this, this can be written as vector A plus B plus C dot again vector A plus B plus C vector. Now simplify this. I will go to the next page. This is equal to, that is vector A plus B plus C whole square is equal to, the simplified this, A dot A plus A dot B plus C, A dot B plus C plus similarly B dot B plus B dot C plus A. And the next step is, so if you follow the same step, what you will get? C dot C plus C dot A plus B. So this is C dot C plus C dot A plus B. Okay. Now, what is this equal to? This can be written as A dot A is nothing but length of A square, B dot B is nothing but length of B whole square, C dot C is nothing but length of C vector whole square, plus A dot B plus C given, it is given that A dot B plus C is equal to 0. So this is 0. B dot C plus C is also 0. C dot A plus C is also equal to 0. So therefore, substitute the value of A. What is A? A is equal to 3, B is equal to 4, C is equal to 5. So this is 3 square plus 4 square plus 5 square. This is equal to 9 plus 4 4s are 16 plus 5 5s are 25. So 9 plus 16 plus 25 is equal to 50. So therefore, the required answer length of A plus B plus C is equal to square root of 50. This can be written as 25 into 2. This is 5 into root 2. So the required answer is 5 root 2 is the required answer for this. So what is the required answer? Length of A plus B plus C is equal to 5 root 2. Hope you followed this. That's it. Listen to me. I will explain once again. So given that A, B, C are any three vectors whose length of A is 3, length of B is 4 and length of C is equal to 5, and each one of them is perpendicular to some of the other vectors, then find the value of vector A plus B plus C, magnitude of A plus B plus C. Now here what is given? The given condition is very simple. Perpendicular means A dot B is equal to 0. Here one of them is perpendicular to the sum of the other vectors, means A dot B plus C is equal to 0, B dot C plus A is equal to 0, C dot A plus B is equal to 0. Now to find, what is required to find is length of vector A plus vector B plus vector C. Now consider length of vector A plus B plus C whole square can be written as length of A plus B plus C whole square. Vector is A vector plus B vector plus C vector dot vector A plus vector B plus vector C. Now simplify this. If you simplify this, what you will get? A dot A plus A dot B plus C plus B dot B plus B dot C plus A, C dot C vector plus vector C dot A plus B. Since A dot A vector is length of A square, B dot B is length of B square, C dot C is length of vector C square. Again, A dot B plus C is equal to 0, B dot C plus A is equal to 0 and C dot A plus B is also equal to 0. That is the given condition. Okay. Now, what is given? Length of A is 3 square, length of B is 4 square, length of C is 5 square plus 0. 9 plus 16 plus 25 is 50. Therefore, magnitude of, that is length of vector A plus vector B plus vector C is equal to square root of 50. That is equal to 5 root 2. This is the required answer. Hope you followed this. Okay. So these are few problems based on the area of a triangle and the area of a parallelogram, and there's some miscellaneous problems. So that's regarding today's session. Let us discuss few more problems in the next session. Thank you very much.